Example 1. An air conditioner supplies air to 3 rooms in a small office premises. The schematic layout of the duct system and the CFM to each room is shown as below. The velocity in the first section is not to exceed 700 fpm. A. Size the duct for the air distribution system using the equal friction method. The duct shall be of standard round sections. B. Estimate the total friction loss if the losses by the diffusers and fittings are 0.02 and 0.05 respectively. For this question, we can separate the air distribution system into 5 duct sections. Section AB, Section B to C, Section CD, Section B to E, and Section CF. Section A to B is the first section that is connected with our fan core unit. The duct length for Section AB is 18 feet. Since Section AB is the first section for the air distribution system, therefore the volume flow rate that flows through this section will be the summation of all the CFM required by the system. Therefore, 600 CFM will flow across Section AB. For Section BC, the duct length will be 8 feet. For Section AB, we know that 600 CFM will flow across this section and 300 CFM will be supplied to Section B to E. Therefore, the volume flow rate flows through Section BC will be 600 CFM minus 300 CFM will be equal to 300 CFM. Section AB and BC can be considered as the main duct. For Section B to E, we know that the duct length will be 8 feet and the CFM required for this duct will be 300 CFM. While for Section CF, we also know that the duct length will be 8 feet and the required CFM for this duct will be 150 CFM. And lastly, Section CD. The duct length for Section CD will be the summation of 15 feet plus 6 feet, which will be equal to 21 feet. And the required CFM flowing through this section will be 150 CFM. Section BE, CF, and CD can be considered as branch duct. Section BE, CF, and CD is the duct line that will be connected to the air diffuser. Now, we are going to develop a table which consists of this information: section, volume flow rate in CFM, the duct length, the velocity in feet per minute, the friction loss per 100 feet, the friction loss for the specific section, and the equivalent round duct size. Now, let's fill up all the informations that we have. We already know the number of sections AB, BC, CD, BE, and CF. We also know the volume flow rate in CFM and the duct length for each section. For Section AB, the duct length will be 18 feet and the CFM will be 600. For Section BC, the duct length is 8 feet and the CFM is 300. For Section CD, the CFM is 150 CFM and the duct length is 21 feet. For Section BE, the CFM is 300 CFM and the duct length is 8 feet. While for section CF, the volume flow rate is 150 CFM and the duct length is 8 feet. From this question, it's already been given the velocity in the first section shall not exceed 700 fpm. Therefore, for section AB, we can feel the velocity is 700 fpm. Next, we are going to refer to this chart. For section AB, we know that the volume flow rate is 600 CFM and the velocity is 700 fpm. Now, we are going to get the interceptions between these two informations. From the interception point, we are going to find the value for the friction loss inches water per 100 feet. And we are going to get the value is approximately equal to 0.065 inches water gauge per 100 feet. We are going to fill the information that we obtain for the friction loss per 100 feet, which is 0.065. Since our analysis is based on equal friction method, therefore, the friction loss along the duct works will be equal. This column is for the friction loss for the specific section. For section AB, we are going to find the values by dividing 0.065 to 100 feet and multiply with the duct length for section AB, which is 18 feet. We are going to get the value is 0.0117 inches water gauge. Similar method will be used to find the friction loss for other sections. Friction loss per 100 feet will be multiplied with the duct length for that particular section. The reason why we divide 0.065 with 100 feet is because we want to find the friction loss for only 1 foot. For the round duct size for section AB, using the information of 600 CFM and 700 FPM, which give us the friction loss over 100 feet is 0.065. Again, we are going to refer to this chart. If we draw a parallel line to the diameter line from the interception point, we are going to get the value for the diameter of the duct is approximately equal to 12.5 inches. Thus, we can feel the value that we obtain from the chart for the round duct size is 12.5 inches. For the remaining section, for example, section B to C, by using the information of 300 CFM and the friction loss per 100 feet is 0.065. We are going to refer to this chart. We are going to find the interception point for the information 300 CFM and 0.065 inches water per 100 feet. If we draw a parallel line to the duct diameter scale, we are going to get the value is approximately 9.5 inches. We can also find the velocity in feet per minute from this interception point. The velocity for 300 CFM and friction losses 0.065 is 600 fpm. Now we can feel the value for the round duct size for section B to C is 9.5 inches. The velocity for section BC is 600 fpm. Similar approach will be used for other sections to find the round duct diameter and velocity by using the information on the CFM and the friction loss per 100 feet. Once we complete filling up all the informations for our table, we're going to determine the total major losses, which is the summation of friction loss for each sections. For the air distribution total losses, we are going to include the major losses which has been calculated previously with the minor losses, which includes the losses from the air diffuser and also all the fittings. For this question, we are going to get the value for the total losses is 0.11095 inches water gauge.